our planet, the Earth. It's a remarkable, ever-changing world, full of natural wonders. But there's more to Earth than this. Because our planet is unique in the solar system, perhaps even in the universe. My name's Ian Stewart, and I want to show you how our planet works. In this series, I'm exploring the 4 powerful forces that have worked together to create our world. Wow. Volcanoes, the atmosphere, ice. But this week, I want to show you the power of the oceans. I'm in the middle of the Atlantic Ocean. It's only when you get out here that you fully appreciate the sheer vastness of the sea. But the oceans are far more than just huge reservoirs of water. They have transformed our planet. Their brute force carves the coastline. And they can leave an extraordinary legacy. They transfer energy around the planet and drive the climate. But above all, we're now beginning to understand how the oceans are connected by an incredible network of currents. Currents that are so critical to the health of our world that when they failed, it led to the greatest extinction in Earth's history. The immense power of the ocean allows it to shape the appearance and behaviour of the entire planet and everything living on it. Three-quarters of the Earth is covered in water. It's why we call it the blue planet. But imagine our world without its oceans. And instead, all that water gathered together in a ball. This is what it would look like. Not that much, really. But this is what separates Earth from every other planet in the solar system. Spread out across the Earth's surface, it transforms our world. The oceans have been here for almost 4 billion years, carving the coastline, driving the climate, and controlling the destiny of life itself. Is Hawaii. It's one of the best places in the world to see the raw power of the oceans. But these waves are so much more than just foaming white water. They are the key to understanding the first great role of the sea. Because what you're seeing is the ocean's extraordinary ability to carry energy around the planet. In this case, it's energy captured from the atmosphere that's turned into the brute force of a crashing wave. Even the mightiest waves begin far out at sea, often triggered by nothing more than a gentle breeze. First, a few ripples form. These act like sails, capturing the power of the wind. Steadily, the ripples grow until they become deep swells. But don't be fooled, this isn't water travelling, it's just energy.
When you look at a surfer sitting on his board, waiting to catch a wave, something strange happens. Although the wave moves forward, the surfer doesn't go there. The wave just passes through, lifting the water and the surfer up and down in the process. In effect, the ocean's just transferring the energy of the wave to the water in front of it.
And this movement of energy is so efficient, it would carry on pretty much forever if the land didn't get in the way. When the wave arrives at the shore, the water becomes shallow, so the base of the wave slows down. But the top runs on ahead until the inevitable happens. The peak topples over, creating the breaking wave. This is the moment when the energy captured from the wind in the distant mid-ocean is finally unleashed. The largest waves crash down with the force of a 4-ton weight landing on your chest. Without water around you to absorb the blow, it would be fatal. But there is another, far greater source of energy that the oceans capture. The energy that creates the tides comes from our nearest neighbour in space. The moon's gravity tugs at the water in our oceans while the Earth rotates beneath it. But the moon doesn't always act alone. On just a few days of the year, the moon and the sun line up together, and their combined gravitational pull unleashes an extraordinary phenomenon that I've come to Brazil to see for myself.
I'm in Arari, small town in the Amazon basin, and to be honest, I'm wondering why. I've flown halfway around the world to be covered in mud and probably rained upon. And all for an ocean phenomenon that I'm not entirely sure is going to happen. But if it does, I'm going to get to see tides behave in a quite spectacular way.
On just a couple of days each year, unusually large tides in the Atlantic Ocean get funneled into the mouths of the local rivers. As the tide rolls inland and gets forced into the increasingly shallow water of the river, it turns into a single, powerful, surging wave. A tidal bore. What we plan to do is to wait for the bore to arrive and then get as close to it as we can.
This tide is a bit unpredictable, and I'm not exactly sure what's going to happen, but what we expect to happen is for a wall of water to pour up from over that direction. Now what should happen is we should hear it first, because you hear a little rumbling. Is that it coming? I think that's it. You can just see along the horizon there a little low froth. Oh my. It's the whole width of the river. We better go now. Yeah? Okay. down must. I was worried that it's the speed of that wave. This is a bloody fast boat and we're just staying ahead of it. This is way ahead.
The energy of the tide is phenomenal. It can roll inland for tens of kilometres, tearing apart the riverbank along the way.
We normally think of rivers flowing out to the sea, but the time stop here means that it goes upstream. I mean, this channel is about 400 metres wide, but the force of the tide makes the river run backward. Woohoo! Look at that!
This tidal bore shows just how much energy is created by the moon and the sun's gravity and released in a tide.
Only going to travel for 25 kilometres. It's going to move about 400,000 cubic metres of water every minute. That's 4 times the flow of the Niagara Falls.
The oceans capture, store and deliver energy, whether it comes from the wind or the gravitational pull of the moon and the sun. The energy is turned into a powerful force that has carved the coastline of every continent. This is a battle for territory between land and sea. It's been fought for billions of years. The northwest coast of America is one of the most dramatic coastlines created by this age-old conflict. But 12 million years ago, this coastline would have looked very different. Even though the cliffs are made from basalt, a particularly tough rock, over the years the sea has attacked every line of weakness. Today, only the hardest outcrops are left behind. They're called sea stacks. But even they will eventually be ground away. Closer to home on the east coast of England, where the sea is faced with a less formidable opponent, the whole process happens terrifyingly quickly. Here, the cliffs are just loose soil. This is what the sea destroyed in just 3 years. Over the last 500 years, the coast has retreated more than a kilometre. But destroying coastlines is only the most evident demonstration of the sea's great power. The oceans influence our planet in many far more subtle and profound ways. They drive the climate. They deliver oxygen to our atmosphere. And below the ocean surface is an extraordinary network of currents that are critical to the well-being of all life on Earth. But 4.5 billion years ago, when our planet was born, it was just a molten inferno. There was no place for any water at all. Yet the ingredients needed to create water were there, locked away deep inside the earth when the planet formed. As the first volcanoes erupted, one of the gases that billowed out was steam, and as the planet cooled, it formed clouds. So began the longest rainstorm of all time. It rained for thousands of years. As the first rivers formed, they began to fill up the low-lying areas on our young planet, creating the first oceans. But it's reckoned that even this relentless downpour only delivered around half the water that makes up our oceans today. The rest came from outer space. This is a comet, filmed in 2005. It's about 6 kilometres across, and like all comets, it's made of rock and water in the form of ice. To discover just how much water comets contain, scientists deliberately crashed a satellite straight into it. As it ploughed into the surface, more than 250 million litres of water burst out into space. In Earth's formative years, it was hit by thousands of comets like this. By the time the bombardment finished, it's thought they'd delivered up to half the water in our oceans. Together, volcanoes and comets gave Earth all the water the planet will ever have. The amount of water in the oceans has stayed roughly the same ever since they were formed about 4 billion years ago. But the oceans themselves are continually changing. As the continents move over millions of years, new oceans open up, whilst others vanish. It's hard for us to grasp because it happens over such an immense timescale. Yet today in East Africa, we can actually see the beginnings of a new ocean. This long, deep fissure in an area of Ethiopia called the Afar Depression is where the planet's next ocean will form. It appeared in 2005, when the land was suddenly ripped open by a massive earthquake. Nearby, similar tears and fractures scar the desert for hundreds of kilometres. This is a continent splitting apart. It may take a few million years, but eventually these cracks will spread, and 3 giant slabs of the Earth's crust will start to separate. In time, a single crack in the desert will have turned into a new ocean. But something as enormous as an ocean cannot simply come and go without having profound repercussions. Take the Mediterranean. This sea has remained a constant throughout human history. Great civilizations have risen and fallen along its shores. Below me is a strip of water that's been fought over for the past 3,000 years. The Romans, the Moors, the Spanish and the British have all battled to control this narrow passage. Because if you rule the waves down there, you control the only gateway between the Mediterranean Sea and the vast Atlantic Ocean.
You control the Straits of Gibraltar.
But that's just our short-term human perspective. In terms of Earth's long history, Straits of Gibraltar have played a very different role, because the Mediterranean is barely clinging to life. This sea, like all seas, is constantly evaporating. The problem is the glare of the sun causes the Mediterranean to lose 3 times more water through evaporation than it receives from rivers and rain.
That means the Straits of Gibraltar are the Mediterranean's lifeline. They might only be 14 kilometres wide, but it's the straits that keep the Med topped up with water from the Atlantic Ocean. If they were to close, then the whole Mediterranean Sea would simply dry up.
It has happened. 6 million years ago, the continents of Africa and Europe collided, closing the Straits of Gibraltar. A barrier had been created between the Mediterranean and the Atlantic Ocean. Isolated, the Mediterranean began to evaporate away.
It seems impossible that evaporation alone can remove an entire sea, but it did. Once the Mediterranean was completely cut off from the Atlantic Ocean, the sea dried away to nothing in as little as 2,000 years.
Just 2 millennia is all it took to transform something as big as the Mediterranean Sea into a desert. You can discover the legacy of this dramatic event half a kilometre underneath the island of Sicily.
This is salt. When the water disappeared from the Mediterranean, this was what was left behind. Millions and millions of tons of it. So much, in fact, that at this salt mine in western Sicily, they're digging out 500,000 tons every year. And they reckon that they can carry on taking that amount for the next 1 million years. Anyone who's ever gulped a mouthful of seawater knows that it's salty. But it's only when you see it dried out like this that you realise just how much salt there is in the sea. For this mine, there's almost more than they know what to do with. So much so that they've even carved their own chapel out of salt, 200 metres underground.
Just like every sea, the Mediterranean got most of its salt from rivers. As rivers flow over rocks and stones, they gradually wear them down. This releases salts trapped inside the rocks, which are carried down to the ocean as sediment. Once in the ocean, the salts slowly become more concentrated by millions of years of evaporation. But salt was not the only thing left behind by the vanishing Mediterranean.
If you're prepared to really search, you can find leftovers that are far more exciting than plain old table salt.
In this cave, there's something so precious that I'm one of the few people who's ever been allowed to see it.
It's like being in a modern art installation rather than a geological cave. Look at that light. This is a geode, and these are giant rock crystals, more than a metre long. This is some of the largest crystals I've ever seen. These crystals form when seawater trickling down from above met hot waters coming up from below. And it was in this mineral-rich mixing zone that these fingers of gypsum grew. And they would have stayed there, submerged, if the level of the Mediterranean Sea hadn't dropped, revealing this geological gem.
Sadly, I can't stay inside the geode for too long, as the moisture from my body will soon start to dissolve the gypsum, which these magnificent crystals are made from.
It's astonishing enough to think that the Mediterranean evaporated once, but in fact, this sea has come and gone many times in the last few million years. And that has had some surprising effects, not just on the geology of this area, but also on the evolution of some of the animals that lived here.
One drop in sea level, elephants roamed over the old seabed. But when water level rose once more, they were forced to take refuge on higher ground, on land that was to become the island of Sicily. We know this because hidden in a remote cave, scientists found the fossilised remains of some of those elephants. But that was only the beginning of the story.
This was unlike any elephant walking the planet today. This is one of its actual bones. Now, it doesn't seem that strange until you realise that this is a leg bone. Now, compare this with the leg bone of a modern African elephant, and you'll see that something is absolutely clear. This Sicilian elephant must have been tiny. Now, I know what you're thinking. You're thinking this must have been a baby, but it wasn't. Tests have proven that this is the leg bone of a fully grown adult, just a very wee one. In fact, at just 90 centimetres tall, this elephant was the size of a goat. The lack of space and food meant that over thousands of years, the elephants evolved into a much smaller animal. Salt mines, crystal caves and dwarf elephants are just some of the extraordinary consequences of a sea that lives on the edge of extinction. Someday, the Straits of Gibraltar will close up again, and then the Mediterranean will disappear once more. Yet the oceans are far more than just reservoirs of water
that fill and empty as the continents move. They are crucial for the way the planet works and for the existence of life itself. To understand why, you have to see them not as individual seas, but as a whole, one single system. Even though we can't live beneath the waves, these vast bodies of water are vital to our very existence. Much of that is down to a group of ocean inhabitants that are surrounding me. Single-celled organisms so small they're invisible to the naked eye. They're known as phytoplankton. Although phytoplankton are no bigger than a pinhead, they're one of the most important forms of life on Earth. To understand just how important they are, take a look at them from space. Just off the British Isles, large patches of the sea are stained light green by millions upon millions of individual phytoplankton, known as blooms. These blooms appear around the world's oceans, and it's because phytoplankton are so abundant that they can affect the whole planet. For a start, they're a vital source of food. Without phytoplankton in the oceans, there wouldn't be any fish or turtles swimming around. Phytoplankton is the first meal in the ocean food chain. But surprisingly, as well as being a primary source of nourishment for creatures in the sea, these tiny organisms help all animals on Earth to breathe. Phytoplankton can do this because they photosynthesize. They turn carbon dioxide and sunlight into energy in order to live. And this releases a very important byproduct: oxygen. This process takes place on a global scale. All these green patches show areas of phytoplankton, and they're all producing oxygen, which fills the seas and the atmosphere. Oxygen is vital to all animals, in the sea, on land, and in the air. If it wasn't for humble phytoplankton, there wouldn't be enough oxygen to breathe. Phytoplankton produce something like 50% of all the oxygen on Earth, about as much as the world's forests and jungles combined. The ocean is the one place where we can't breathe unaided, and yet ironically, this is the very place that provides us with half our air supply. But producing oxygen is just the start of it. The secret to the sea's power over all life on Earth, its greatest power, is a vast network of currents that connect all the oceans on the planet. The complexity of this network was graphically illustrated by a curious accident.
On the 10th of January 1992, an ocean freighter was caught in a big storm out in the middle of the Pacific Ocean. As winds and waves lashed the ship, two of its giant containers crashed overboard, and their contents spilled out into the sea. What burst out of those containers was, bizarrely, a shipment of these plastic bath toys. More than 29,000 ducks were now adrift in the middle of the Pacific Ocean. No one realised it at the time, but this accident would eventually turn out to be one of the biggest experiments in the history of oceanography. These ducks were about to embark on an epic voyage of scientific discovery.
The moment they hit the water, the plastic ducks joined a series of powerful ocean currents which scattered them in different directions. In just 7 months, some were carried over 3,500 kilometres, washing ashore in places as far afield as Hawaii and Alaska. But for other ducks, the voyage had only just begun.
They had embarked on a treacherous journey north, up through the Bering Straits, and into the Arctic Sea.
For the next few years, the ducks were carried east, in ice floes across the Arctic and out into the North Atlantic, finally coming ashore on the coasts of eastern Canada and northern Scotland.
You know, these tough little plastic toys had been carried for thousands of kilometres across 3 different oceans simply by the power of those surface currents. And they're still turning up today.
The ducks' epic journeys vividly reveal the complex system of currents that connect all the oceans together. Currents that are vital to life on the planet. They carry nutrients and oxygen that nourishes life, and heat that drives the climate. In fact, the oceans are giant reservoirs of heat that's been captured from the sun. When heat-sensitive cameras are used to reveal the temperature of the ocean, you can see how the heat is distributed. The warmest areas are, as you'd expect, near the equator, where the sun's rays are at their strongest. But the ocean's heat doesn't all stay at the equator. The network of ocean currents distributes it around the planet. It's like a massive central heating system. And one of those currents is pretty important to us here in Britain. It's perhaps the most famous of all the currents. It brings warm tropical water from the Caribbean and delivers it right here to the British Isles.
It's known as the Gulf Stream, and this is one of the first places in Europe that it flows past. These are the Isles of Scilly, just off the coast of Cornwall. And since it's such a beautiful spring day, I thought I'd enjoy the warm, balmy Gulf Stream waters for myself. Well, if this shows you one thing, it shows you that all things are relative. I might not be able to feel the warmth of the Gulf Stream just by jumping straight in, but you can see the effects of it all over the place. Just not here.
Winter temperatures in the Scilly Isles rarely fall below freezing, creating a near Mediterranean climate, allowing tropical plants and exotic animals to survive. That's because air travelling over the Gulf Stream picks up heat and moisture from the sea, and the Scillies are the first landfall for that warm, wet air. You get some idea of how powerful the Gulf Stream is by travelling around the world on the same latitude as the Scillies. Heat-sensitive cameras show the waters off southern Britain glowing a warm orange. But on the other side of the Atlantic, at the same latitude, greens and blues reveal the icy waters off Canada. The Gulf Stream is just one fascinating example of how the atmosphere and the ocean interact to drive the climate. It's easy to assume it's the atmosphere that drives our weather patterns, and of course in part that's true, but in terms of moving heat around a planet, it's ocean currents that are the driving force. There's actually far more heat stored in the ocean than is held in the atmosphere, and this means that changes in the ocean currents can have big effects on the weather around the world. In the Pacific, every few years, a warm current moves from west to east. It's seen here as an area of red and white. No one's quite sure why it happens, but we know it as the infamous El Niño, and it's responsible for transforming the weather across much of the globe. It brings torrential rain to South America, flooding the normally dry deserts. While on the other side of the Pacific, in Australia and Indonesia, the opposite is true. They are starved of moisture and suffer terrible droughts. Just by altering the flow of this single ocean current, weather across the planet is thrown into disarray for months. Yet even this isn't the full extent of the influence of ocean currents on our planet and on life. To get the complete picture, you need to dive to the depths of the ocean. Only recently have scientists been able to explore this strange and alien world. They've discovered another system of currents that travel in the deep ocean. It connects with the warm surface currents to form one great network. It's called the Great Ocean Conveyor, and it's one of the most powerful forces on the planet. It's made up of warm currents that travel on the surface and colder currents which are found deep at the bottom of the ocean. The conveyor links the entire planet. It transports oxygen, nutrients and warmth around the world. It's vital to the health of all life on Earth. But the conveyor wouldn't keep flowing if it wasn't for what happens in the cold northern oceans. This is where the surface water sinks to join the deep water currents. The sinking happens because the water's very cold, which makes it dense and heavy, so it plunges to the bottom of the ocean. And it's this sinking water which keeps the entire conveyor moving around the world. As it travels south, it hugs the seabed until it warms at the equator, where it rises to complete the circuit. Without cold water sinking at the poles, the ocean conveyor would collapse. If that were to happen, then the sea would no longer be supplied with oxygen and nutrients. It would become stagnant and lifeless. It takes roughly 1,000 years for the ocean conveyor to go all the way around the world, shifting masses of heat, food and oxygen along the way. It's the ocean conveyor that controls the well-being of the entire planet. Without it, our world simply wouldn't function. you only fully appreciate just how important the ocean conveyor is to life on Earth when it goes wrong. It's happened before, and it resulted in the death of almost every living thing on the planet. This catastrophe happened 250 million years ago, and these were the creatures in the firing line. They weren't dinosaurs. This was an age well before dinosaurs walked the earth. It was a time of increasing global warming. Rising temperatures made life hard, but things were about to get much worse. As global temperatures continued to rise, the oceans warmed up so much that the cold water at the poles could no longer sink. The crucial link in the ocean conveyor had been broken. So the ocean currents stopped moving, and the sea became a graveyard. You can find evidence of the devastation this caused in an unlikely location. The Dolomites, a jagged range of mountains on the border of northern Italy and Austria. This might look just like solid black rock. It's so much more than that. It's actually the remains of billions and billions of dead sea creatures, all squashed together. These are the remains of animals that died when the ocean conveyor stopped working. They're halfway up a mountain because millions of years ago an ocean covered this whole region. It was squeezed out of existence by the land around it, which forced the seabed to rise up, creating these mountains. As the seabed rose, it brought the remains of these dead marine creatures with it. This layer of black rock can be found all around the world. It shows that life in the oceans was utterly devastated by the collapse of the ocean conveyor. Once the conveyor had stopped, oxygen was no longer carried down into the deep sea from the surface. So as oxygen disappeared, the marine life which relied on it died out. Eventually, nearly all life in the oceans perished. That's exactly why this rock looks the way it does and why it's so special. Whenever you find black shale like this, you know you're looking at the remains of billions of plants and animals that have died because the oceans ran out of oxygen. But that was just the beginning of the devastation. Mysteriously, it was followed by the extinction of almost every living thing on land as well. This lack of oxygen, known as anoxia, explains all the death in the ocean, but it doesn't explain why the extinction spread onto the land. We know that it did because the remains of millions of land animals have been found across the world. But the link between land and sea isn't clear. That is, until you discover what was brewing in the depths of the stagnant oceans. This is Green Lake in New York State. It's a mini version of what the oceans were like 250 million years ago. It may look normal, but below the first few metres, the water is stagnant and oxygen-free. It's become like this because the lake's incredibly deep and has only small amounts of fresh water flowing into it. Scientists dive here to discover more about how those ancient oxygen-free oceans cause such devastation to life on Earth. It's risky work. They can only stay in the lake for a few minutes because something deadly lurks in these waters. You know you found it once the water turns pink. This tells you you're swimming in a highly toxic poison. It's called hydrogen sulfide, and it builds up when water stagnates. If you dived down into the oceans 250 million years ago, this is what you'd have seen. Fortunately, today the hydrogen sulfide in Green Lake stays trapped in the water. But back then, so much of it was being produced that it began to bubble out of the ocean and into the atmosphere. So now, almost every creature on the planet was exposed to a gas as deadly as cyanide. What began with a breakdown of the ocean conveyor would end in the greatest mass extinction in Earth's history, and the death of more than 90% of all life on Earth. The story of what happened when the ocean conveyor failed is a striking reminder of just how much life on Earth depends on the health of the oceans. Fortunately, events like a complete breakdown of the ocean conveyor are rare. It's unlikely to happen again in the near future. In fact, we can count ourselves lucky that conditions in the world's oceans have barely changed since human beings have walked on the planet. That is, until now. Today the oceans are facing a new threat, and it's us, human beings, that are the cause. We are now pumping massive amounts of carbon dioxide into the atmosphere. We know this is leading to climate change and increasing temperatures on the land, but it's also affecting the oceans in ways that have never been seen before. To see what could be in store, I've come to Paradise, the tiny islands of Palau in the South Pacific. The marine life here is highly sensitive to small changes in the water, so this is a good place to see how the oceans react to rising levels of carbon dioxide.
In recent years, the island communities of Oceania have experienced changes of the sea that they've never known before. And the most dramatic affected a community of animals found nowhere else in the world.
This is a golden jellyfish. They're found in these large saltwater lakes that are almost cut off from the sea. And there are millions of them. Although they look rather scary, they're totally harmless to humans. These giant swarms of jellyfish are spellbinding. But this is a sight that might not be around for long if temperatures continue to increase. That's because these jellyfish are extremely sensitive to changes in water temperature. A few years ago, they were almost wiped out. This is such a beautiful, idyllic spot. It's hard to believe that an ecological catastrophe happened here. But in 1998, sea temperatures throughout the region increased by almost 2 degrees. Now, that may not sound a lot, but for these jellyfish, it was a disaster. It's estimated that up to 20 million of them perished. Just 2 degrees of warming was enough to almost annihilate an entire species. Fortunately, this was caused by a short-lived variation in the local climate. Once the waters began to cool, the jellyfish were able to recover. But it's a stark warning of what could happen if the world's oceans keep warming because of climate change. Many other ocean ecosystems are just as sensitive to small temperature increases. But the seas around Palau are also vulnerable to another threat related to carbon dioxide. And it's potentially far more serious than increasing temperatures. It's called ocean acidification. It happens when carbon dioxide in the atmosphere dissolves into the sea. In the past, levels of carbon dioxide changed only very slowly, so the oceans had time to adjust to any increase in acidity. The problem is that today we're pumping out so much carbon dioxide, the ocean just can't keep up. As a result, they're turning acidic faster than they have for millions of years. And this could have a devastating effect on life in the sea. The first creatures that will suffer will be the coral that make up the world's great reefs. Their skeletons can't form if the water becomes too acidic. If the oceans continue to acidify at their current rate, coral could eventually disappear from our oceans. With the coral would go all the other life that depends on them. For ocean acidification, we have a far greater impact on the death of coral reefs. Change in the ocean's chemistry threatens the overall balance of Earth's life support systems. The health of our planet is so intimately connected with the conditions in the sea that these changes may have untold consequences for our world. If ocean acidification continues, coral would be just the beginning. Phytoplankton are also vulnerable to increasing acidity in the sea. In the long term, this could endanger one of the main sources of oxygen on the planet. But what about the short term? What will these changes in the oceans mean for us? The thing is, the oceans have been stable for millions of years. We are heading into uncharted territory. So we really don't know what the full implications are likely to be. What we do know is that the oceans are fundamental to all life on Earth. Ultimately, the survival of every creature on the planet depends on the oceans remaining healthy. Now, our presence on the planet is changing not only the temperature, but the chemistry of the oceans. If the history of the oceans has taught us anything, it's that when the sea is pushed too far, life on Earth suffers. In a battle between man and the sea, there's only going to be one loser, and it's not going to be the oceans. Next, I'll be looking at the outrageous good fortune that helped make Earth a home for life, to discover if the forces that shaped our planet are unique in the universe.
And the final part of the series is next Tuesday at 9. Exploring the awesome beauty of our mountains. Next tonight on BBC HD, Griff Rhys-Jones explores the Pennines.